x-intercept, how to calculate a y-intercept, but more generally, we just learned what x and y-intercepts are and a special trait that each one of them had. Right? We learned that x-intercepts always have y values of 0 every single time. I'm just going to put that right there. The x-intercept of a graph of a relation has a 0, y-coordinate with a value of 0. X-intercept, y equals 0. That's like the important part to start off any of those x, y-intercept questions. Alternatively, the y-intercept of a graph relation has an x-coordinate with a value of 0. So when you're talking about your y-intercept, you have an x-coordinate of 0. And that was kind of the trick of doing everything we did yesterday. Then we did some algebra, we did some graphs, we did a wide variety of stuff. But it all kind of came down to those two ideas and remembering how to do that. Awesome. Domain and range. This is one of the more important things that we're going to do this year because domain and range carries forward all the way through high school. So you take dash 1, dash 2, doesn't matter. It's going to be domain and range every class until you graduate. So it's a useful thing to really try to understand this year so that in the future years it's not so hard. Okay. We'll start off by talking about domain. So if somebody asks you, like, what's the domain, what they're asking you is, what are all the possible input values you could have for a question? And that changes depending on the question. But by saying, what's the domain, they're saying, what are the input values? A reminder, input values are our x values. All right, so domain is asking for possible x values on a graph or an equation. On the flip side of that, range is asking for possible output values. So if I say, okay, what's the range of this graph? What I'm saying is, what are the possible y values for this graph? Okay? Because range, output, and y values are all talking about the same thing. Outputs are y values. We have two different ways that we're going to do domain. Okay? There's ways for discrete data, and then there's ways for continuous data. So it's different depending on the type of data you have. Typically, we have continuous data, so that's when we do the most of. But every once in a while, we have discrete data, and it's a much easier way to do it. So we're just going to slide on down to class example 1. And we're going to list the domain and range for the following set of ordered pairs. We'll start with domain. So if I want to do the domain, domain is asking me, what are the possible x values? The first thing I have to do is decide if I have discrete or continuous data. This is discrete data. The reason why is I can just count them, right? There's 5 things there. There's nothing connecting them. There's no lines. It's just like ordered pairs. Ordered pairs are always just discrete values, just discrete data. To do domain for discrete data, you go D, colon, and then curly bracket. Mathematically, that's how it looks. If I were to read it, I would read this as domain is, and then the bracket is containing all of my possible input values. Right? So the D stands for domain, the colon stands for is. Domain is. And then it's really easy. I just list out all my possible x values from smallest to greatest. So if I'm looking at ordered pairs, x values are my first numbers. I order them from smallest to largest. My smallest x value is -3. My next smallest x value is 0. Next smallest, 1. Next smallest, 3. Next smallest, 5. And then I close it with a curly bracket. This says the domain is -3, 0, 1, 3, 5. Those are all the possible input values or x values you have in this question. Not bad, eh? To do the range is the same thing, except you're going to go R, colon, curly bracket. Range is possible y values. So for this question, if I want to do my possible y values, I list them from lowest to highest. My lowest y value is 2, and I actually have 2 of them. You only have to put it once, right? I'm not asking how many y values are there, I'm asking what are the possible y values. If I say 2 is a possible y value, I've covered both of them. The next highest possible y value is 5, then 8, then 9. And then I close it with a curly bracket. Try the second one. So see if you can list the domain and range to the second set of ordered pairs we have over there.